All right, now we would like to control the speed of conveyor using the potentiometer. So you can see that this potentiometer is giving a reading from 0 to 10.0. This is giving 0 to 10 volts. Okay, we want to use this reading, and where we will push it. If you remember, in the PLC logic, we have parameter dB. Okay, we have parameters in a dB, in the dB data conveyor, and in this parameter we have defined 3.0 as a start value, because this was a fixed value. But now we are having a variable value which is coming from the potentiometer. So the first step is we will remove the startup value. Basically we will make it 0. All right, and now we will push the value from this potentiometer directly to the potentiometer, or directly to the parameter of I speed. Okay, now if you remember, in the read function we are reading the value of potentiometer, which is going to this value, data I input IR speed, which is basically this one. We have took the input speed, which is going here from the potentiometer. We have done this already. Okay, so what we have to do is we have to just move this value to the speed value here. So this speed will go to the parameters. Okay, so we can just write one line here. So this is reading the value. This is one way of doing it, and this is getting the value from here. If you want to see the value here, okay, I will come back to that later. Now I will download the logic, and we will just notice if we get the speed in the parameters. Okay, everything is downloaded. Now if I see, my potentiometer is already giving some reading, 4.5, but we don't see reading here. We don't see reading here. That's strange. Okay, let's troubleshoot that, because sometimes we find problems. So let's see the watch table first, and notice if we are getting the value here. Strange enough, we are not getting the value in the PLC tag. So if we see here, this potentiometer is going to ID 100, and ID 100 is here, and we are not getting any values. Okay, we need to see if there is any confliction of the addresses. So I will go back to my PLC maybe and check its properties. And in the property we have overview of addresses, and here we notice ID 100 is not being used as of now. Okay, we have to check maybe IO addresses, which looks fine. Okay, all right, let's go to the device and network, because I remember I have some devices connected here, which is also part of the course. So we have this IO link device. I think this will be a confliction. This is also part of the course. We will learn about that later. So if I go inside this device and notice its IO addresses, here has a problem. This is reading from 90 to 122. So this address space has been reserved by this IO link. And because my ID 100 falls into this range, 100 is in the range of this IO addresses, there's a confliction. So one solution is I will go to configuration. I will make input word starting from 200. Output word can also be 200. Okay, and then I go back to my driver, so it's automatically to 200. And this is also to 200. Okay, perfect. So we go back, and now we go back to the PLC tags. So instead of 100, I make 200 here as well, just 200, and here as well 204. I am sure this is correct. Just to confirm, 204. Perfect. So you notice I just changed the tags, and now we know that the tags are linked into our DB automatically, so I don't have to change anything in the DB. So this will automatically, this DB converter will automatically read from 200 now, because this is defined in the read function and the write function. So this is the benefit of using functions and moving the value from tag to DB, so that your internal programming remains same, internal assignment of addresses remains same. You just have to make changes to your tag. So I'll just load it now, and now we will see if we get the readings here, which I'm sure we should get. So configuration is loaded and you have seen the values are here. And these values are coming from here. So this was 4.5. And I can move the values up to 10, 0. So we have proportional value coming directly into the parameters. Now this is coming to the parameter because we just added a line here that we are reading the values IR speed. This is the IR speed into parameter, into this parameter. Okay, so this is directly linked in the read function. I don't have to do that in the main function. So coming back to our FB, and we go online, and you will notice the speed here is the speed which is in the potentiometer, because we are moving this value into the parameters. So I can just start my conveyor and I can notice the change in the speed. Rest of the programming is same. I start the conveyor. This is the maximum speed. You can see the feedback of the conveyor 10.0, and now the speed is decreasing. Here speed is 21%, quite slow. So we have seen how to move the values between DBs and function blocks and finally achieve what we want. So this was the idea of this video, how to move the values and avoid confliction of IO addresses. Alright, now in the next video we will make a complete logic. Alright, but before that I want to make some changes here, because we notice that when the motor is running forward, this is in positive. If it's running reverse, it should be negative. So how to make it reverse here? This potentiometer is from 0 to 10. So let's consider this potentiometer only as a speed. So I will rename this maybe speed 0 to 100%. Okay, and instead of controlling the direction from potentiometer, I would prefer to take a selector switch. This would be a good option. This switch will define the direction of our motor. I can put it here. Okay, and I want to make one more changes. I will come to that a bit later. So state 0, let's make it forward. State 1, reverse. I'm sure you pretty much have an idea. If I want to make it reverse, I have to make the speed parameter in minus. Okay, so I have to multiply with -1. That we will see that in the programming lesson. So we need a selector switch to change the direction. And instead of this error here, I would like to have a stack light, which will be more interesting. So let's just move it maybe here. Start stop is fine. Let's move this here, here, and bring it up. Oops. Yeah. Now we'll take a stack light, because stack light will have more LEDs which will define if the motor is running or the conveyor is running, or if it is stop, or if it has an error or e-stop pressed. This looks pretty nice here, and that's fine. So in the next video we will write a logic, and we will use all the controls. We will use e-stop, we will use the indication when the motor is forward or reverse, start stop buttons, changing the direction, controlling the speed, monitoring the speed, and in case if we have some errors, we can also do that. If e-stop is pressed, we can do some blinking and stuff like that. So I will see you in the next video. Thank you.